Hello, I welcome you all in my YouTube channel Coding by Fun, and let's get started. So today's question is to find the height of a binary tree. So we have example, and here 1 is the root node, 2 is the left part of it, and 3 is the right part of it. So its height is 2. As you can see, there are 2 levels, 1, 2. So how height is 2. Yes, similarly you can see here there are 3 levels, 1, 2 and 3, so output is 3 and we have to find the height. The task is to complete the height function. As you can see, there is already a height function is given to us and we have to complete it, and they have passed node pointer root as an argument, and they are expecting the time complexity of order of n and also the space complexity of order of 1. So I think we can do with the help of recursion. So let's see the concept of recursion first, then we will continue here, right? So let me show you the concept of it, and yeah. So let's see, I have a tree, binary tree, and its structure looks like this. This is 1, this is 2, 3, let's say 4 here, and let's say 5 here. So what I will do, I am using recursion. It means recursion means stake. You have to use a stake, right? Recursion uses stake to solve the problems. So initially 1 is passes as a root to the function, right? Now what I will do, I will recursively call the left function. Let's say I am maintaining a height in the left, height of root of left, and in the right I am maintaining the height of root of right, and whatever will be maximum I will take it and I will simply return. So let me write the code first, then I will show you the logic part, right? So let me write the code first. So if the root is null, then I will simply return 0, right? Otherwise what I will do, I will make the 2 integer type variables into left. It will store the height of left. I am recursively calling the height function and passing root left, and similarly I am making a right function where I will call the height function, right variable, sorry, I am calling the height of root of right. And what I will do now, I will simply return max of both. So for finding the max, I am making another variable max equals to left. If left is greater than right, then I will simply pass the left in the max variable, otherwise right will be there in max. So I will simply return max plus 1. 1 is for that node, right? So now let's look at the logic. So again I am taking the same example, 1, 2, 3, and make it short and just take this tree, right? So I am passing 1 as a root node, so it's a root. Now it is not null, right? So let's make a stake here, right? For every node I am maintaining the data here so that it will be easy for us to remember from where we have to continue, right? So first of all we are here and we have to call the left, so we are calling height of root of left. So let's say I am at node 1, right? I am calling this function. Let's say it is line 1, it is line number 2, and it is line number 3, and this is line number 4, right? So I am at node 1, I have executed the 1, and I had to execute later when I will come to 1. What are the lines I have to execute? 2, 3, and then 4, right? Now I am calling the left part, then I am here at 2 now. So I am at node 2, and similarly I am going left, and I will call 2, 3, 4 line later on. So I am now here 4. So I am calling left function for this, and similarly I will call 2, 3, 4 line later on. Now I am going to next of it, left of this 4. Now found that it is null, right? So I will simply return 0. So I will return 0 to 4th node, right? So I am returning 0 to left. Now in left I have returned 0. Now I will call this second line because I have returned to the 4. Now at 4 I have to execute second line, third line, and fourth line. Now I am executing the second line, right of it. So at the right there is also null, so it will return 0. So in right I am getting 0, right? Now in max I have made a max function which is getting the maximum of this, which whatever the maximum, but here both are 0, so I can make here equal to sign. If left is greater than or equals to right, it means both are same, then also the value will be put into the max. So max, we are returning max plus 1. Max is 0 plus 1, that is 1 will be returned. So we have executed a second line, third line, and also fourth line because we are returning here. So we are returning from 4th node to 2nd node, right? So we have executed only the first line of the 2nd node. It means whatever we return will become in this left, because only through the first line we have executed it and going down. So 1 is returned from the 4th node to 2nd node. So now left of this 2nd node is 1, right? Because 1 is returned from here. Now we are executing the second line for this 2nd node. Second line is right, we are calling the right function. So in the right there is nothing, so it will return 0, right? For node 2, in right there is nothing, so it will return 0, same, right? And whatever will be maximum is 1, so max will return 1 plus 1, that is 2 will be returned from node 2. So we have executed third line and as well as fourth line, so we are returning 2 from here. Now for first node we have executed only the first line and we are returning something, and 2 is returning 2, so that 2 will come in this left because we have executed only first line. So this 2 will come in this left, right? Now we are executing the second line of first node. So second line says we have to move to the right part. Okay, we are moving to right part, right? Now there is 3. So again for 3 we have to execute all this fourth line, but initially we are going for left, so there is nothing left, so it will return simply 0. And similarly in the right we have executed first line, left there is nothing, it will return 0. In the second line there is nothing, it will return 0. And third max will get 0, and fourth it will return max plus 1, that is 1 from here will be returned, right? So to return 2, that is for the first node I have executed second line, and when 2 returned to first node it returned 2, right? So left contained 2, and now the right returned 1. It means the right contained 1. So this 1 and 2 line are over. Now I'm executing the third line. third line says maximum of both, so maximum of both is 2. So in max there will be 2 for this node, right, for this one node. Now I'm going for the fourth line, and fourth line says return max plus 1. So max plus 1 is 2 plus 1 3. So 3 will be returned by first node. It will return 3. It means 3 is the height of the tree. As you can see also, it is 1 is on first level, second level, third level. So 3 is the height. So we got the height as 3 for this tree, right? So let's compile this code and check it. So I'm compiling it. Alright, so let's compile it first. To check we are getting the output as 2 for this node, for this tree or not. So it's taking time. So it was easy, just the concept of recursion is used, and yes, we are getting 2 as an output, as you can see. Now let's submit to check we are passing all the test cases of this code or not. So I think yes, we have passed all the test cases. So guys, if you like this video, you can share with your friends, and we have discussed the recursion concept as well as we have find the height of binary tree. So that's all in this video. See you next. Bye.